Look at this crazy document, this engineering document, very complex, very hard to deal with this in RAG. Now look at this. Beautiful, clean, descriptive JSON that you can use in any RAG or LLM application. This is really hard to do. I'm about to show you how. Hi, I'm Neil.
And my name's Daniel.
And we are from iLevel.ai, the makers of GroundX RAG on-prem. Now, GroundX RAG on-prem are APIs to build enterprise-grade RAG on-prem, air-gapped in your own data center or in your managed cloud. We do this with enterprise-grade accuracy, security, and scalability. But what we want to show you today is something we call a bit of a magic trick. It's how we handle complex documents like the one that you see in front of you here. Now, we've trained a vision model on nearly 1 million pages of documents just like this one, but also from healthcare and legal and industrial and all these different industries. And we've merged the vision model and a VLM together. It enables us to do what I'm going to show you right now. What you see in front of you is something we call an X-ray, which is a proprietary tool we built to help evaluate complex documents and how we turn them into LLM-ready data. The boxes you see on this screen are essentially our vision model predicting where complex objects are that will cause downstream hallucination. So where's the table, where's the form, where's the graphic, where are complex text blocks. And once we know those positions, if I click on this, you'll see what we turn it into. Now, first of all, we recognize it's a figure. If it's a table, we call it a table. And we produce a number of important artifacts for every object. First, keywords. We produce keywords to improve RAG search. We summarize the entire document, and this goes into the retrieval. So this improves LLM completion because the LLM has context of where this chunk comes from and what it's fundamentally about. And then we produce 2 really important artifacts for the object itself. First, narrative text. Now, the purpose of the narrative text is to describe this object to a language model as if it is blind, because a language model is basically blind, especially completion models. So we describe it conceptually, and then we drop the clean JSON. So let's go into what we actually are able to produce here. I want to back out here again for a second. I want to show you a little detail. So this is obviously a fan of some kind, and it's 6.77 inches wide with a tolerance of 0.02. It's 172 millimeters wide with a tolerance of 0.5. So if I click on this, here's how we describe this. The document features a diagram of the MA1751 series fan, highlighting dimensions and performance characteristics. The fan's diameter is specified as 6.77 inches wide with a tolerance of 0.02, equivalent to, as I said, 172 millimeters with a tolerance of 0.5. Kind of amazing, right? Now, look at this JSON. Again, type description. This diagram illustrates the dimensions of the MA1751 and its various characteristics. And then we get into the components here that are described. It's breaking down every little piece, essentially, of this diagram so that you can do, essentially, RAG search and then ask sophisticated questions of sophisticated documents. So the first component here is the fan's dimensions with the diameter of 677 or 172 with the tolerance here of 0.5. Or 0.02 in inches, and so on. I want to now show you one other thing. And I don't want Daniel to jump in and explain how developers can really use this. Check this out. If I scroll all the way over here, check this out. This is a pretty complex diagram here. It's basically showing the relationship between, when the fan is operating, the relationship between static air pressure and airflow. And it has these kind of long curves and points on to describe that. If I click on it, here's where we describe this. The performance graph plots static pressure in millimeters of water against airflow in cubic meters per minute. These curves, labeled UX, EHM, and L, show a decreasing trend in static pressure as airflow increases. So look, we're not good enough to nail every single point on this chart, but conceptually, we can describe it to a language model. And then you can do things like this. And then Jenna is going to jump in and explain how we develop with this, explain the tech specs of the DC axial fan in great detail. And in about 10 seconds, we should get a really great answer. But the whole core of this is, state-of-the-art agentic workflow for document understanding, so that you, at the end of this pipeline with almost no work, can get really clean, beautiful RAG on really complex documents. And here's some of those details. Daniel, what do you think? This is a tough document. What do you think?
Yeah, I think it's super cool. And it's turning document like vague, amorphous, designed for humans. There's stuff in random places. It works for the human eyeball, and it's turning it into something that a language model can understand. And I think it's really important to really kind of talk about the implications of that. There's so much information in these types of documents. And if you can just tap into it, you can build some of the most amazing LLM-powered, things. It's super cool. Let's work through some examples, right? So now you have this document, but now it's in JSON. So now you can, for instance, use a rewriter to write it into a specific schema that can be used for an application. So you don't even have to build like a formal AI thing. You can take this JSON and turn it into a schema that can then be used for programmatic workflows. You could also build this into some sort of agentic workflow that's designed for understanding. We have built a whole RAG system on top of this. So you can imagine a bunch of documents. Now you have a bunch of this clean JSON across a whole knowledge base. Now you can use, your traditional RAG workflows to inject those into a language model. It all starts, all of these amazing things. You could build sort of a constrained agentic system with sort of kind of graphs. You can build maybe a more open-ended thing like a React style agent. You can build, the world's your oyster. And it all starts with understanding the freaking document, which is what this does. It turns it into text. So it's like the beginning of this, the world's your oyster type of spawning point, which I think is super exciting.
Thanks, Daniel. Love that. Well, listen, visit us at ilevel.ai. I challenge you, bring us your insane documents and, come ready. And the first 5 million tokens are free. Upload your documents, take a look at the X-ray, and see if it works for you. And let us know. Love to hear from you.